Okay, the other one we're doing here is 2002 free response, and it's a lab one. So the first question is, what are the units of Q, MC, triangle T? So delta T. Q is going to be in joules or kilojoules. M would be in grams. C is joules per gram degree Celsius, or if you picked kilojoules, it needs to be kilojoules per gram degree Celsius. And T is going to be in degrees Celsius. We could also change these Celsius for kelvins, and that would be acceptable too. Then we need the measurements to attain the value of Q. So we know we need the initial and final temperatures. Then in this equation, we're going to want the mass of the water. We're assuming the mass of the water and the mass of the solutions, that they're basically the same thing. That the particles that make up the solution are kind of negligible. So you could write the mass of the water or the mass of solutions. You could also have chosen to do the volume of the solutions, because if you know the mass, you can figure out the volume using density, and if you know the volume, you can figure out the mass. So that's why the key says mass or volume. Okay, so then we have to figure out how to calculate each of the following. The number of moles of water formed during the experiment. So what you needed to know was H plus and OH minus is going to make H2O. The confusing thing is they don't give us the volume. So you have to use the molarities, and you would say molarity times the volume of the H plus is going to give you moles of H plus. And then you could say 1 mole H plus for every 1 mole H2O. Okay, or you could have just as easily done the OH, but it's a 1-to-1 ratio, so they're just making sure that you're not saying add the two together, because that's not what happens. It's 1-to-1 ratio. 1 mole of H plus reacting with 1 mole of OH will give 1 mole of H2O. The value of the molar enthalpy, enthalpy has an H in it, so I know that that means delta H. Oh, it's given to me. Enthalpy of neutralization for the reaction between HCl and NaOH. So how are we going to find delta H? We're going to find Q equals MC triangle T, and then it's going to be the negative of that, because the heat is going into the water, and then the reaction is the source of all the heat, so it needs to be the negative of that. And we want it in joules per mole, so we're going to take the joules and divide by moles of H2O, I guess. Okay. Then it says the student repeats the experiment with the same equal volumes as before, but this time he uses 2 molar NaOH and 2 molar OH. Indicate whether the Q increases, decreases, or stayed the same. And Q is going to go up here because if you have the same volume but more moles, so we have more particles reacting, we're going to get twice as much heat. It's just like if you take, if you burn a log versus if you burn a house. So the more stuff you have, the more heat you're going to have. So Q is going to increase. Indicate whether the value of the molar entropy of neutralization will decrease or stay the same. And we know it's going to stay the same because we're looking for the molar enthalpy, so we'll take those joules, and even though there's more joules, we'll be dividing by more moles, so we'll get the same value. Okay. Suppose a significant amount of heat were lost in the air during the experiment. What effect would this have on the calculations? That question all the time. If we lose heat, we're going to have a smaller number of joules, but our moles will probably be the same, and so we would expect to have we would expect delta H to be smaller. Okay.